Let's take another example of a two-noded bar element. We've been given that the cross-sectional area is 1.2 inch square and the Young's modulus, the displacements at nodes 1 and 2 is given. We are asked to find out the displacement at point P, the stress and strain, element stiffness matrix, and the strain energy of the element. So we know that Q1 is 0.02 inch, Q2 is 0.025 inch, L equals to x2 minus x1, and that is 23 minus 15. So the length of the bar is 8 inches. Zeta in terms of x is given by 2 by L x2 x minus x1 minus L by 2. Substituting all these values, we get zeta as 0.25 at P. We are asked to find out the displacement, so we need the shape functions n1 and n2. n1 is given by 1 minus zeta by 2, and this works out to be 0.375. n2 is 1 plus zeta by 2, and this is 0.625. So the total of this you see is 1. The displacement at point P can be found out by using this formula n1q1 plus n2q2, and on substitution we get 0.023 inch. In part 2 we are asked to find out the stress and the strain. The stress of a bar element is given by EB into Q. B can be written as 1 upon x2 minus x1 minus 1 x2 is 23, x1 is 15, so this is 1 by 8 minus 1 Substituting the other values, E is 30 into 10 to the power 6 psi, and Q is given by Q1 and Q2. Taking these two terms inside the vector, so this is a 1 by 2 vector and this is a 2 by 1. When we multiply this 2, we should get just one value, and this works out to be 18750 psi. So this is how we get it. It's minus 3.75 into 10 to the power 6 into 0.02 plus 3.75 into 10 to the power 6 into 0.025. We found out the stress. Now the strain is given by stress upon Young's modulus. The third one, we are asked to find out the stiffness matrix. Stiffness matrix for a one-dimensional element is given by this formula, AE by L, 1 minus 1 minus 1 1. A is already given to us as 1.2 square inch. On taking these terms inside the matrix, we get so this is the stiffness matrix for the one-dimensional bar element. In the last part, we are asked to find out the strain energy of the element. The strain energy is given by capital U, and we write it as half UTK into U, or we represented it as half QTK into Q. So we know that Q is Q1 and Q2, which is given by 0.02 and 0.025. Q transpose, so we invert this column vector into a row vector. Okay. K we have just found out, it's 4.5 into 10 to the power 6. It's a symmetric matrix, 2 by 2 in size. And Q is 0.02, 0.0225. Now this is a 1 by 2 vector and this is a 2 by 2 vector. This is 2 by 1. First let us multiply these two and we get when we multiply this, we should get a vector of size 1 row and 2 columns. So it is minus 2250 and 22500. 0.02, 0.025. Now here we have a 1 by 2 and a 2 by 1. When we multiply, we'll get only one value. So the strain energy works out to be 56.25 and the unit of it is pound inch. This solves our problem. This is the last thing we were asked to find out. Thank you.